Hey there, Gregory Carlson here with College Algebra. Let's start section 4.3. So up to this point, we've been doing exponential functions and inverse functions, and now it's time to bring those together. The inverse of an exponential function is a logarithm. And so we're going to talk about logarithms, and there's some tricky math that we're going to look at, and it's tricky because it's something that you're not used to looking at, and so that's why I'm going to explain it. So what you're going to see is a statement that looks like this. Log base 5 of 125. And what you're going to need to know is that this right here represents a number. Okay? Log base 5 of 125 is a number. And you need to figure out what that number is. And in this case, the number is equal to 3. So why is log base 5 of 125 equal to 3? And here's how it works. I cannot visualize this. I have a very difficult time visualizing log base 5 of 125. Instead, what I do is I convert it back into an exponential, which is what it is. Log base 5 of 125 equals 3 means the same thing as 5 to the 3 equals 125. Basically, when you see log base 5 of 125, you're asking yourself the question, 5 to the what power equals 125. So 5 to the what power is 125? And the answer is 3. But again, when I said there, 5 to the what power is 125, that's why that log simplifies to 3. Now you can see why these logs are going to be useful, because we're going to be able to use them to solve questions about finding exponents of equations. So here's the big idea. When you see log b of a equals g, don't think about it this way. Instead, convert it in your mind to b to the g equals a. So just remember, this right here is your exponent. And it's nice because the small number is your base. And so notice that that's your base. So base to the exponent equals the number that's floating right here. 5 to the 3 equals the number that's floating right here. So hopefully that makes sense to you. Again, don't visualize this. Instead, convert it to something that you're more familiar with, which is b to the g equals the number that's just sitting at the end. So let's do that to solve a few questions. So let's look at the first one, which is log base 2 of 32 equals x. So again, I don't think about it this way. I think instead, there's my base, 2 to the x equals 32. So 2 to what power is equal to 32? So count on your fingers. 2 times 2 is 4, 8, 16, 32. So if we take 2 to the 5th power, we get 32. So therefore, x is equal to 5. Because 2 to the 5 power equals 32. What about this one? This one looks strange. Log base 10 of 0.000001. What would that be? Well, hopefully you can kind of get a clue already. This is going to be a negative number, because remember, when we take a power of a negative, it flips it and makes it a reciprocal. So again, notice that there's no variable in here. You should mentally put equals x, or whatever variable you want, into this. And so in other words, 10 to the what is equal to 0.000001. So 10 to the what equals that. It's going to be a negative number. So let's think about it in scientific notation. 1, 2, 3, 4, 5, 6. This over here is 1 times 10 to the negative 6. So that means the answer is negative 6. So let me just say that again so that you understand how I got that. Look at my calculator. I'm going to put in 10 to the 6 and then throw a negative sign. So 10 to the negative 6. Let's see if my numbers match. 0.000001. 0.000001. So that's how I kind of did that one. And you can sometimes just do trial and error in your calculator, or just convert this into scientific notation would be the best way. How about this next one? Log base 3 of 27. So 3 to the what equals 27? Well, 3 times 3 is 9, times 3 is 27. So we're trying to solve 3 to the x equals 27, and the answer is 3, because 3 to the 3 is 27. Let's do a few more. Log base 10 of 10,000 is equal to what? Or, in other words, the base to the exponent, remember it equals the exponent, equals 10,000. Well, 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000. So the answer is going to be 4. And so that you're sure you're correct, do it again on your calculator. 10 to the 4th power equals 10,000. Let's do a few more. Log base 4 of 64. And again, remember, oftentimes that equals x is not going to be there. You need to mentally put that in, because that way it makes it easier to think of it like this. Okay? So if you see log base 4 of 64, you should be able to translate that to 4 to what power is 64. That's what this represents. It represents an exponent. So 4 times 4 squared is 16, and 4 to the 3rd power is 64. And again, if you're not, I know all of these because I've done them so many times, but if you're not sure, just do 4 times 4 equals 16, times 4 again equals 64. So x equals 3. You should have a log button on your calculator that you can do these, but the trouble with the log button is that it's log base 10. So we'll talk about that later, but you'll notice if I put in 100 and then click log, because it's base 10, it's always going to do it in base 10, so that's 2, right? Because 10 squared is 100. Notice that if I put in 100 or 1,000 and hit log, I get 3. If I put in 10,000 and I hit log, I get 4, and so on. If I do 1 divided by 10 and I hit log, what do you think I'm going to get? Hopefully you thought -1, because 10 to the -1 is equal to 1 over 10, which is a tenth. So the calculator is not going to be useful for anything that's not base 10. Okay, it'll work for these base 10 problems, but for nothing else. But we will find a way that we can use the calculator here soon. All right, let's do this one. Log of 9 of 81. So in other words, 9 to the what equals 81. 9 to what power equals 81? And hopefully you know that that's just 2. 9 squared is 81. So hopefully going through these examples has made sense for you. What I want you to try to do is try to do these 6 on your own. See if you can get them. And so pause the video now, see if you can get these 6, and then I'll do them. So go ahead and pause really quick. I'll give you a little extra time. All right, hopefully you pause the video and you got an answer to these. Let's do log base 5 of 1. In other words, 5 to what power, or you can even put a question mark there if you want. 5 to the question mark equals 1. So 5 to the what does equal 1? Well, the answer is 0, because anything to the 0 equals 1. So that's interesting. So if you have a log with a 1 right here, there might be a way that we can always get an answer for that. Because remember, anything to the 0 equals 1. So we'll talk about that in a second. What about this one? 230 log base 234 of 234. That would be 234 to the what equals 234. And again, put a question mark here or put an X or whatever you want. The answer is going to be 1. This question mark or X is going to equal 1 because 234 to the 1 equals 234. How about this next one? 6 to the what equals the square root of 6? Well, remember that how do we write a square root as an exponent? Hopefully you remember that the square root of 6 is equal to 6 to the 1/2. So that means that 6 to the what is the square root of 6? The answer is 1/2. So that one was kind of tricky. because 6 to the 1/2 turns it into the square root of 6. So we just passed 10 minutes. Let's take a break here, and we'll finish up the rest of these and come up with a few general rules for the next video. So see you there.